Okay, to summarize what I've talked about so far, we have our two opposing pressures that are going to be governing bulk flow of fluid across the capillary wall. We've got our hydrostatic pressure, which is going to encourage filtration. It's going to push fluid out of the capillary. And then we have our colloid osmotic pressure, which is going to encourage absorption. It's going to pull fluid into the capillary, okay? If we want to determine whether filtration or absorption is occurring at a particular location along the capillary, we can do that by calculating the difference between these two pressures, okay? So our net pressure is going to be our hydrostatic pressure minus our colloid osmotic pressure, okay? If we end up with a positive value, that means we're going to get filtration. If we end up with a negative value, that means we're going to get absorption. So, as you might have guessed, I'm going to be asking you to calculate the net pressure on the arterial end of this capillary here and the net pressure on the venous end of this capillary here. So go ahead, hit pause, and make that calculation. Okay, so let's go over those calculations. Again, remember that our net pressure is going to be the hydrostatic pressure minus the colloid osmotic pressure. On the arterial end, we have 32 millimeters of mercury minus 25 millimeters of mercury, which gives you 7 millimeters of mercury. And on the venous end, we have 25 millimeters of mercury, we have 15 millimeters of mercury minus 25 millimeters of mercury, which is going to give you negative 10 millimeters of mercury. Therefore, since we have a positive value here, we're going to get net filtration at the arterial end. Since we have a negative value at the venous end, we are going to get net absorption. So just like I pointed out in the first slide about this topic, now you know why we have net filtration on the arterial end and net absorption on the venous end. Okay, so there's one last thing that I want to talk about about this topic about bulk flow in the capillaries, which is the fact that overall we get net filtration out of the capillaries. Okay, so to take a look at why this happens, let's look here, right? So notice that in this like sort of example capillary here, okay, that hydrostatic pressure is going to be greater than colloid osmotic pressure for most of the capillary, maybe 2/3 of the length of the capillary, whereas hydrostatic pressure is less than the colloid osmotic pressure for sort of the last bit, okay? Since we have a higher hydrostatic pressure than osmotic pressure for most of the length of the capillary, that means overall we're going to get net filtration out of the capillaries. We're going to filter out more than we absorb back in. And over the course of a typical day, we will actually be losing 3 liters of water out of our capillaries every day. That is a lot of water. So I'm not sure if I ever said this before, but our total blood volume is about 5 liters, okay? If we're losing 3 liters a day out of our capillaries, that's kind of a problem. That's like 60% of our total blood volume, right? So we don't want to be just losing water to filtration out of the capillaries every day. We want to recover that liquid in some way, right? So how do we do that? It turns out we do that using our lymphatic system, okay? So what is the lymphatic system? The lymphatic system is a series of vessels. They're kind of, they're like dead end vessels. They don't form a complete continuous circuit like this cardiovascular system does. But we have these dead end vessels. They're shown in green here. And we have a series of nodes as well, okay? Lymphatic system plays a big role in the immune system, but I'm not going to be talking about that. What I want to be talking about here is just their role in draining our fluid from the tissues of our bodies. Okay, so when we lose fluid from our capillaries to filtration, what happens is a lot of that fluid is going to then move into our lymph vessels, also by bulk flow. So same mechanism, okay? Once that fluid gets picked up by our lymph vessels, it gets returned to our circulation because the lymph vessels drain into our vena cava, okay? So that's how we recover the fluid that we lose to filtration at the capillaries. Oh, and finally, I just want to point out this term, edema, which is what can happen if you accumulate fluid in the interstitial fluid. So if you are not properly draining using your lymph vessels, if your lymph vessels aren't picking up that fluid, then we end up getting a buildup of fluid in the tissues, and that gives you edema.